Hello everybody, and welcome to the second part of the Unity networking tutorial brought to you by Netrix Gaming. So, we left off last time by setting up the basic networking system. We could spawn a remote player and see it move around, but the movement wasn't really all that great. So, today we're going to fix that. If you haven't done so already, let's open up your project and let's go to the player prefab that we've created. If you've been following along, it should be in the prefabs folder. Since we're going to be using our own script to send and receive position updates, we no longer need this network transform component on the player, so we can remove it. Now let's go ahead and open up our player script, where we will add some variables and some functions in order to update the position ourselves, so we can kind of smooth it out a little bit. Okay, so here's our player script. The first thing that I like to do whenever I'm going to be accessing another component on the game object is go ahead and create a reference to it, so we don't have to keep on getting it using either get component or through the built-in variables, which can sometimes cause some performance issues. So since we're going to be working with the position of the player, we need the transform. I'm just going to go ahead and call it my transform. And then down here in the start function, let's go ahead and fill that in. Okay, so we've got the transform. Now we need a variable to store the incoming position from the server for other players. So let's create a vector3 and name it. Let's go ahead and name it player position. Okay. So now that we've got our variables there, let's go ahead and create a function to send our position to the server. We do this through a command, and all commands that are sent from the client to the server must have this command attribute, plus it must have cmd in front of the function name. And for this one, I'm just going to call it send position. And we're going to be sending a vector3 with it. Now all the client does is send this function to the server. It actually doesn't run any of the code contained within this function. So all of the code that's in this function is only going to be ran on the server. And we can go ahead and assign the player position here, and that's going to equal the position passed to it. Now we need a function for clients to receive this new position. And we do that through a client RPC. And like the command, these client RPCs have to have RPC within the function or method name. and we're going to be receiving that vector 3. And what we're going to do on this is the same thing that the server did, is save that position to this variable. And now up here in the, well, also the code that's in the client RPC is only ran on the client. But up here in the command function that the server runs, we can go ahead and tell it to call that method so that it sends that RPC out to all of the clients. And we're just going to send that position. Okay, so usually in a network game, you don't want to be sending messages like this command in this RPC, like every frame, or else you're going to bog down your network and you're going to bog down your server, and it's just not going to run very well. So what we need to do on the client is only send it every so often, and then the other clients can figure out the movement themselves in between positions that we send them in a fairly accurate way. So I like to accomplish this through enumerators. You can also use things like the invoke method that's built into Unity, like invoke repeating and then some method name. But I like to go ahead and use an enumerator. So let's go ahead and create a function that's going to handle sending the player's position to the server every so often. We're just going to call this update position. And in this enumerator, we're going to run it to run all the time that this player is active. So what we can simply do is go while enabled, run this code. But we don't want to block the client or sit there and just send it, right, and do nothing else. This would actually block the client where it couldn't do anything else. So what we need to do is add a yield statement, and we're going to return a new wait 4 seconds, and we're going to create another public variable up here where we can set how long we want to wait between position updates. I'm just going to call this, and it's going to need to be a float. I'm going to call it position update rate. Now I'm going to set it to an initial value of something like 0.2 seconds. So it's going to send about 5 times per second. And we can go ahead and add that, or fill this in. So what this is going to do is sit there and just keep calling whatever code we put in here every 0.2 seconds. So what we want to do is simply call this command, and we are going to pass it our current position from our transform. Okay, so now we need to make sure that we start this enumerator, and we only want to start it if we are the player, or if we are the local player. We don't want to send other players' positions, and the server wouldn't allow it anyways. So let's make sure that we put this in the is local player block. And we can start the coroutine and just pass in that method there. And we should be good to go on that front. But now that we're getting the position every 0.2 seconds, we need to update that remote player. Now currently, we will be getting position updates for ourselves as well. So we'll need to handle this in the function where we handle updating our the remote player's position. So I'm going to create a new method called lerp position. And you're going to see why I call it lerp in just a few seconds. And remember, if we don't want to lerp our own position if we are the local player. So we can simply do a if is local player, then we return out of this function. We don't want to have anything to do with this. It's only for remote players. And here what we're going to do is update the position of this remote player, and we're going to do it by vector3.lerp, and it's going to expect 3 different things. For the first variable that it wants a starting position, and our starting position is just our current position. And our next variable that it wants is the position that it's going to. And that would be we called it player position. And then it wants a float. And this is where it does its smoothing. And we're going to use time.delta time, and we're going to multiply that by our smooth rate. And what did we call that? We called it, oh, we haven't created it yet. Let's go ahead and create a float up here, excuse me, called smooth. Let's see, what would be a good name for that? I guess for now we can just call it smooth. And I want to set that to an initial value of something like 4. Or actually, let's go ahead and change it to something a little bit higher. Maybe 15. And we'll see how that does. And since we've made them public, we can change this in the editor in game and test out different update rates and the smoothing. So let's go back down here and finish this out. Okay, let's look over our code, make sure there's no errors, make sure things make sense. Okay, we need to do one more thing. and we need to go ahead and add the update function, which we got rid of in the first part of the series. And this is called every frame. And we just want to go ahead and call this alert position every update. In this code right here, the time.delta time, as you can see, is the seconds that it took to complete the last frame. So what we're doing here is we're smoothing it out based on your frame rate. Okay, let's go ahead and save this. Let's open up Unity, or let's go ahead and bring it back up. Okay, so we've got all this good stuff set. Let's save the project just to make sure. Then let's go ahead and build and run and see what happens. Okay, let's go ahead and start this back up. And we want to host the match here. And one little trick, if you haven't figured it out yet, if you're in this first person mode and you hit escape to get the cursor back, try to get it in the position that you want, and then move outside of the game window and then click, and it will stick wherever it was pointing whenever you clicked. Here, let's join as a client. Let's go ahead and move this window. Okay, so it's still kind of moving in not a very smooth way. You know, it's still kind of jerky and choppy, just not very nice looking. So remember I said earlier we can go over here and play with these values while the game is running to try to find something that's more appropriate. Right now it looks like it's smoothing, or that's a little too high. Let's go ahead and lower it to something like 5 and see what happens. Okay, that is much better, but it's still not all that great. You know, you can still notice it a little bit. Let's go ahead and lower it just a little bit more. Okay, that seems a lot better. Okay, let's look at it from this view. Let's go ahead and undock that. Let's just start. Okay, well, it's not going to show in the game view since we only changed the values in the editor over here. Let's go ahead and change those values for good, since the 4 looked pretty good. So let's change the smooth to 4. Let's go ahead and build and run again. Okay. And we want to look at it through the actual game's view, so that looks just a lot smoother. But one thing that we can notice is, like, whenever we jump, it kind of looks like they're floating back down to the ground. And that's not really realistic. And there are several different ways that we can approach it and try to fix it. And we'll get into that a little bit more later in the series, to also implement some type of system that takes into account for lag. And because let's just see what happens if we simulate a little bit of lag. And we can do this over here on the network manager. And let's go ahead and check use network simulator. Let's change the latency to, let's say, 176, and the packet loss to maybe like 0.2%. Let's save the scene, and then let's build and run again and see what it looks like with just a little bit of lag. Let's join. And we can see that we have a little bit of a problem here. It's not wanting to connect at all. And the main reason for this is, more than likely, we have too much packet loss. So for now, let's just set that to 0, and let's move our latency down just a little bit and see what happens. And I haven't played around with the simulator since 5.2, so there might be a little bit of a bug with that. I know there was a bug before with it, but I thought they fixed it. So let's go ahead and try again. No, actually, it's not a bug. It's due to whenever we use the network simulator, we need to use it in a build. I'm pretty sure it does not work if the editor is hosting the server, and I had forgot that. So we're going to just simply start the server in the built game. And we get a little pop-up. And in the editor this time, we're going to be the client. And see how it took a little bit of time to spawn in? That's the simulator working. Oh yeah, we can definitely see some lag. Uh-oh, yeah, so much lag that we disconnected. Let's try to rejoin, see what happens. Okay, we can rejoin. we can definitely tell that's not smooth anymore. And there it goes. So let's see, that was just with 114 millisecond lag, which really isn't all that uncommon. Let's try without the packet loss. Oh, and we ran into the same issue we had in the last series with the game still being open, or that I ran into. So we need to back up a little bit more. So yeah, we're still lagging. Way too bad, causing disconnections. And really that shouldn't happen with this low of latency. So one thing we can try to do is go over here to the player, let's edit this script again. First, let's go over here and look at okay, so let's look here. We have quality of service channels. Channel number 0 is reliable sequenced, meaning that any message that you send on that channel, it's going to get there come hell or high water. You know, it's going to get there no matter what. Channel number 1, though, is unreliable, meaning the client or server could send it and forget about it. Let's try changing our movement to unreliable. And we can do this by adding an attribute. Let's change this to 1. And let's see what happens now. Because I think that we're getting kicked, basically, or disconnected, because we're just getting so out of sync. Oh, and I changed it in the wrong project. Okay, so we have changed the network channel. Save the scene, build and run. And I always like to save, and once you really get into building games with Unity, if you're not already, sometimes Unity crashes, and if you're sitting there working on a prefab or something in a scene and it crashes, you've just lost everything up to the last save. So I like to save often, like you should with everything. And if you don't, you'll probably run into a few instances. I have many times, and I still, sometimes it happens even whenever I do save often. Okay, so, yeah, we're still getting disconnected from the lag. And I'm, for the next series, or the next part, I will try to look into see if there's a bug or something, because it should not be disconnecting with just 114 millisecond latency. So yeah, I can see the ping timeout is 500 milliseconds, so it shouldn't be timing out on us. And our update rate here is only every 0.2 seconds, so 200 milliseconds. So yeah, I'll try to look and see if there's a bug in it. For now though, let's just disable this network simulator. And in the next part, we're going to be looking at adding some more gameplay-like features, something like a simple weapon, and also getting it to sync where it's aiming. If I find out what's up with the network simulator, I'll try to throw that in there as well. And probably from there on, we will look into much more game-like mechanics, since we have this basic networking system in. We can send and receive things. One thing that we will need to cover is the sync var for things like health. But we will be getting into that very shortly. And even cooler things in the next chapter. So I hope y'all enjoyed this, and I will see you guys later.